Hi there, Algebra 2. 4.8 Complex Numbers. You've always heard these stories about imaginary numbers. Today you are introduced to them. Objective: to identify and graph, perform operation with complex numbers, and to find complex number solutions of quadratic equations. Imaginary unit is a solution to the quadratic equation x to the second plus 1 equals 0. Imaginary number is any number of the form a plus bi, where a and b are real numbers and b is not equal to 0. Complex numbers is a combination of a real number and an imaginary number in the form a plus bi. Pure imaginary number is an imaginary number of the form a plus bi, where a is 0. So, if a is 0, you're just going to be left with b times an imaginary number. So you're going to end up with an imaginary number. There is going to be nothing, no ors, buts, or about it. Complex number, it says it's a combination of a real number. A is going to be a real. B is going to be multiplied by that imaginary number there. Complex number plane is a geometric presentation of complex numbers are established by the real axis and the perpendicular imaginary axis. And we'll do a couple of those graphs here in a little bit. Absolute value of a complex number. This is when we start getting into the complex part. I'm trying to think exactly. We'll get into it. I can't think exactly what to call it right now. Complex conjugates, each of the two complex numbers having their real parts identical and their imaginary parts of equal magnitude but opposite sides. Alright, square root of a negative real number. For example, for any positive number a, you have square root of negative a here. Then they break that down, and obviously you can factor this a little bit. You get negative 1 times a. Then they're going to take the square root of 1 times the square root of a. The square root of 1, the big thing we're learning today, is the square root of negative 1 is going to be I. That is the thing we're going to learn today. The thing we got going over here, it tells us the square root of negative 5 equals I square root of 5. Alright, let's check to see if that's right. Alright, we can break this down. We can have negative 1 times 5. Alright, that is the square root of negative 1 times the square root of 5. Alright, it's supposed to equal this. Alright, imaginary number, you have negative 1. Negative 1 square root of negative 1 is I. Can we take anything out of the square root of 5? No. So we get them to be equal. So that is a correct statement. Okay? This should be a 5, none of this. Alright, there we go. Alright, how do you write negative 18 by using imaginary unit I? Alright, once again, square root of 18, you are going to have negative 1 times 18. Now we have the square root of negative 1 times the square root of 18. This is going to give me I. This we can break down a little bit more. We can take the square root of 9 and times the square root of 2. Square root of 9, if you know anything about your perfect squares, that's going to give me a 3. 3i square root 2 is your answer. Alright, we're going to do kind of a similar thing here. We're going to break down. We got square root of negative 1 times 12. Alright, which is really the square root of negative 1 times the square root of 12. Once again, you can break 12 down. You're probably going to go 4 and 3. Take the square root of both of those. Alright, square root of negative I, you're going to get I, or square root of negative 1, my bad. You're going to get I. Alright. Then, right here, you're going to take the square root of 4. Well, that's going to give me 2. Can I take the square root of 3? No, so we leave it like this. My answer. Alright, over here, we got the square root of 25. Alright, so we got negative 1 times 25 in the square root. Alright, square root of negative 1 times the square root of 25. Well, square root of negative 1 is going to give me what? I. Alright, square root of 25 is going to give me 5. There's my answer. Alright, we got C here. We got negative 7. You're going to have the square root of negative 1 times the square root. Alright, well, all of them the square root on this one. Now you're going to have the square root of negative 1 times the square root of 7, which this is going to give me I times square root of 7, because square root of 7 I can't take anything out of. Those are my answers for those. Good. Alright, complex numbers. You can write a complex number in the form a plus bi, where a and b are real numbers. If b equals 0, the number ab is a real number. So b equals 0, 0 times I is going to give me 0. Still, that rule still is in effect. So that means you're just going to get a real number. If a equals 0 and b does not equal 0, the number abi is a pure imaginary number, because you're going to take imaginary number times b, which is just going to give you a pure imaginary number. Now, we've learned about real numbers. Those are rational, irrational, counting, natural numbers. That all goes over here. Today we're working more on this other side of this deal. We have imaginary numbers. And then we have pure imaginary numbers, which are numbers, like we said, where a is going to be 0. Alright, what are the graphs and absolute value of each number? Alright, so if I graph this, we have 5. 1, 2, 3, 4, 5. Minus I. So we have a line here, and we're going down here, and we're going to have I. Alright, the reason we do this is because of the fact we want to find this distance from here to here. We want to find that one. Alright, and this is when we use that absolute value. I couldn't remember where it was exactly or what it was, but I wanted to not say the wrong thing, so I ended up just keeping my mouth shut. Alright, you got 5 minus I. This in the book will tell you that this absolute value is going to equal, so actually if you want to get real technical, the formula is a minus or plus b of I equals a squared plus b squared, and that's all on square root. Alright, so a this time is going to be 5 minus I. Okay, we have a, which square root, a, which is 5 squared, plus b, which is going to be a negative 1 squared, and then you're going to do square this. You get 25 plus 1, and square root of that. Alright, square root 26. That is my answer. That is the distance it is from I here to this number right here. With the imaginary and the real coordinate plane. Alright. Now, we also have right here b, negative, on b we have negative 3, 1, or negative 3 minus 2i. So once again, we're going to have negative 3, 1, 2, 3. We're here, so we have a line right here. Alright, we're going to go down 2i. So we're going to say this is 2i. Now, we want the distance from here to here. Okay? So we're going to come over here, we're going to put it into this equation. Alright. And we're going to get negative 3, the absolute value of negative 3 minus 2i, absolute value. Now we're going to sub in a, which is going to be negative 3 squared plus negative 2 squared we are going to get 9 here plus 4. This is square root. Square root of 13 is our answer. Okay? Now we're going to do this one. We have 1. I'm going to make my 1 a little bigger so you can see it really easy. We have 1 there, and we're going to go up here for 4i. Alright, then we want to know the distance from here to here. So we're going to come over here and plug it into this formula. So, we've got we've got 1 plus 4i in absolute value equals square root of 1 squared plus 4 squared. So now we're going to end up getting 1 plus 16. Alright. And then you get the square root of 17. That is your answer for C. Alright. Now, we have adding these. You need to think of this like adding with variables. You can only add like bases. So, like that, we think of 2x plus 1 plus 3x plus 5. I can combine this and this because they have the same variable. Their bases are the same. I get 5x to the second plus, I can add this and this and get 6. We're going to be doing something very similar to that today. Okay? We can add this. Alright, let's add our 7 and our negative 3. We get 4. We have negative 2i plus I. We're going to get minus I. That is my answer. Alright. We come over here. This is a minus, so I have to distribute this negative to everything. Alright, now I'm going to combine it, and I get 1 minus 3, which is going to give me what? Negative 2. Alright, plus 5i plus 2i, which should give me 7i. There's my answer. Okay, once again, got to change this, distribute the negative all the way through. Okay, the 8s are going to cancel out, so this one, 8 minus 8 is going to give me that. We have 6i plus 6i, which is 12i. Answer. Okay, now we have negative 3 and 3. There's that, they cancel out. We have 9i and 9i, which is 18i. There is my 4 answers for this. Alright, we did adding, we've done subtracting with imaginary numbers, now we're going to multiply. Now, once again, treat this like x's. This is x and this is x. I'm going to get 21x to the second, right? Because I multiply my coefficients, then I multiply my exponents, so I get x to the second. Because you add the exponents when you multiply variables. Alright, so now we're going to have 21 by multiplying 7 times 3. We have I times I, which is going to be I squared. Now, the square root of negative 1 got us I. So how would we ever get negative 1? Well, we'd have to square I. So this is actually equal to a negative 1. So we're going to get 21 times a negative 1 and get 21, and that is my answer there. Alright, here we're going to do some foiling. First, we're going to get 8 outer, so we're going to get plus 10i. Inner, we're going to get negative 12i. Last, we're going to get negative 15. 15 i's to the second. Once again, I times I is going to give me that. Okay? We're going to combine what we can. 8 plus this, which will give me minus 2i minus 15i to the second. Now, I to the second, if we recall, that's a negative 1. Negative 1 times negative 15 is going to give me 8 minus 2i plus 15, which when I add that, I should get 23 minus 2i. All right. Once again, FOIL, we're going to get 16 minus, we're going to get positive 20i, because a negative times a negative is a positive. When we do the inside here, we're going to get negative 20i. And when we do the other one, we're going to get minus 25i to the second. This is going to cancel out, leaving me 16 minus 25i to the second. I to the second, if you recall, is negative 1. Negative 1 times negative 25 is going to give me a positive 25. Add those together and I get 41. That is how you multiply imaginary numbers. All right. Now we are going to divide. When we divide, we're going to have to use a complex conjugate. What a complex conjugate is going to be the same thing here, but different signs. And you've probably done that with numbers, but now with this imaginary stuff. So, we're going to have the same numbers, 3 minus 4i over 3 minus 4i. All right. The reason I can do this is if I divide that, what do I get? Well, I only get a 1. Well, I'm not adding anything to it or multiplying anything to it if it's just 1, right? All right, so we FOIL. We get 3, well, we get 6, or 9. We get 9, we get minus 12i plus 12i, and then we get minus 16i to the second. That is my denominator. My top, I'm going to go above. I don't really want to, but I'm going to get 15. Then I'm going to get 20i. Then I'm going to get minus 6i. And then we're going to get plus 18i to the second. Or 8i to the second. All right. I'm going to simplify this. This is going to give me negative 26i. That's gone. This would give me a minus 8. So I'm going to have 15. So I'm going to end up with 15 minus 8, which is 7, minus 26i. Here, I am going to get this to cancel out. And then this is going to become negative 16 times negative 1, which is 16, plus 9, which is over 25. That is my answer. Okay? All right. Now this one, we just got to multiply by negative 6i. Minus 6i. All right, when we do that, we're going to end up with negative 36i to the second. On the bottom, up top, we're going to distribute that. We're going to get negative 24i. When I distribute it here, when I go here, I'm going to get plus 6i to the second. All right. When I do that, this is going to end up being simplified and get me 36. This over here is going to get me negative 24i minus 6. All right. Now, we're going to separate this. So this is going to be 36 divided by 36. Dividing each portion of it. My minus sign in between it. Can we reduce this? Yes. We can take out a 12. We get negative 2 over 3i minus 1 over 6. That is my answer for that one. All right. This one, we multiply by 8 plus, no, it'd be minus 7i. We do the same to the top. All right, we're going to, on the top, we're going to get 64 minus 56i minus 56i. And then we're going to get plus 49i to the second. Over here, we're going to end up getting 64 minus 56i plus 56i minus 49i to the second. This is gone. Up here, it's going to end up getting me 64 minus 112i minus 49 over 64. This is going to give me plus 49. Alright. This is going to give me 15 minus 112i. And this is going to give me 113. Can't be reduced. That is my answer. Alright, factor form of each expression. Okay. First one, can we take out, first thing we always want to check, can we take a number out of both of these? Yes, we can take out a 5. Alright. We end up with x to the second plus 4. The other day, we said we're done. Now we have these things called imaginary numbers that make life really good. When you do imaginary numbers, you still have to get x to the second, and you're still going to have to get plus, or get this to be a perfect square. It's still having something to do with the perfect square. So we're going to have a 2, and we're going to have a 2. I'm going to go plus and minus now. And then I have to have an I squared and an I squared. What this is going to do is I'm going to get, or I get x to the second plus 2ix minus 2ix, so that cancels out the middle, which is what I want to happen here. Alright, and then I end up getting minus 4i to the second. Well, we don't want a minus 4, but wait, we have an I to the second, which is negative 1. Negative 1 times negative 4 is going to give me positive 4. So this right here would be our solution. Now, the longer you do this, the more you're just going to realize that this is x and x again. Can't take anything out of this right off the bat. Nothing in front of that, so I know I can't take anything but a 1. That doesn't need me yet. Alright, now we need to factor the 81. We're going to have a perfect square here. We have to have different signs because of the fact that we're working with these imaginary numbers. Okay? But we have to throw an I in here. Because I squared is going to change that sign. Our middle's still going to cancel out like it did last time, like it did right here. But we're going to end up with technically a minus 81, I to the second. Well, that I to the second is going to make it so we can multiply